Lesson 19 in Module 3 is on unknown area problems on the coordinate plane. So a couple things we want to pay attention to here. We'll be dealing with area, and a lot of our information is going to become from counting on the coordinate plane. Okay, so couple new formulas, maybe, or review some formulas that we've known in the past that we're going to need to use today as well. Okay, so the coordinate plane below contains figure P. That's this right here. Okay, this parallelogram, because opposite sides are parallel. And it says, and I'm sorry, this copy did not come out real well. It's going to be hard to count, but we'll make it work. Draw a rectangle surrounding figure P that has the vertex points of A and C, and label those two triangles S and T. And it sounds really confusing, but again, all we're doing is I'm drawing a rectangle that fits in parallelogram P right here, right? Okay, so, but it creates a couple right triangles. Okay, this one right here, we'll call that one S, and this one right here, we'll call that T. Okay, so that's all we have to do for that one. Now it says find the area of the rectangle. Okay, so again, mine didn't turn out real well. Hopefully yours turns out better. But I'm really going to just count the sides. I'm going to count from this point to this point, okay? And my rectangle I can see is off a little bit because it's really, we want it right on. Oops, sorry about that. There we go. Okay, so if I count, I'm going 1, 2, 3, 4, 5, 6, 7, 8. Not the best counting job I've ever done, but we'll say this side is 8 units long. Okay, now over here, 1, 2, 3, 4, 5, 6. No, I think it's only supposed to be 6, isn't it? 1, 2, 3, 4, 5, 6. Yes. All right. So if we want to find the area of a rectangle, remember our area of a rectangle formula is length times width. 8 times 6, or 6 times 8. Remember, multiplying doesn't matter the order. And that's going to be 48. Okay? We don't know if it's inches or centimeters or whatever. So I'm just going to say it's square units because SQ is going to be the abbreviation for square there. I'm going to need 48. And if I could see here, there'd be 48 squares. Okay? Now, the next one might be a formula that hopefully is new, is review for you. It says find the area of each triangle. Okay, so we're going to have triangle S and triangle T. So we need the area formula. Okay, so I'm going to find the area of triangle S. And the area of a triangle formula is 1/2 the base times the height. Now, you might have seen it as base times height divided by 2. Same thing. Okay, same thing. So if we're taking the area of, sorry, mouse is going a little crazy here. Okay, if I'm taking the area of triangle S right here, I need its base and its height. So I look at the two sides, the legs they're called, that make up that right angle, and I count them, okay? Well, obviously this side here is going to be 6, and right here it's going to be 1, 2, 3. So this is a 6 by 3 triangle. So I'm going to go 1/2 times 6 times 3. Does it matter if I do 3 times 6? No. Okay? Does it matter the order that I multiply these in? No. Does it matter if I put 0.5 in a calculator and go 0.5 times 6 times 3? All good ideas. Because it's multiplying, I'm going to go 6 times 3. That's 18. Half of 18 is 9. Okay? So the area of triangle S is 9 square units. Means I need 9 squares to cover it. Okay? But now I'm going to find the area of triangle T, and I'm going to use the same formula. Actually, I'll do the other one you might be familiar with. Base times height divided by 2. These two are equivalent. Multiplying by the half is the same thing as dividing by 2. Okay? So now for T right here, I know this side is 6, and this side is 1, 2, 3. Might help if I make marks at the correct places. Sorry. 1, 2, 3. So I am going to go 6 times 3 and divide it by 2. Well, 6 times 3 is 18, divided by 2 is 9. So they're really equivalent. Now notice the next one says use these areas, 9 and 9, to find the area of the parallelogram, A, B, C, D. So what we want to find the area of right now is just A, B, C, D. I want just this inside here. So if you think about this for a second, we know that the whole area of this whole thing, this whole big rectangle right here, is 48 square units, okay? And I'm actually just going to do that problem up here by the side, okay? So the area of this whole thing is 48. But I don't want this, and I don't want this. So I have to take out those two areas, okay? So I could, go 9 plus 9, because the area of each of these is 9, and subtract it off. Or I could think of it as I have the area of the whole thing, which is 48, and I'm going to take off this 9, so minus 9, and take off this one, minus 9. Okay, these two are, remember, equivalent. Any way you do that, okay, you're going to get 30. 48 minus 9 is 30. Or 9 plus 9 is 18. 48 minus 18 is 30. So we get 30 square units, okay? So the area of parallelogram P is 30 square units, okay? Now it's a lot of work, right? We can do it. It's a lot of work to get to that. So let's look at maybe another example. This one's a little different. This is rectangle R here, and it says find the area of rectangle R. No problem. I know the area of a rectangle formula is length times width. So all I have to do, and again, my picture didn't turn out very well, is we have to count, okay? So this side right here, this length is 1, 2, 3, 4, 5. Okay, so I know its length or its width, doesn't really matter, is 5. Now if I go up here, it's 1, 2, 3, 4, 5, 6. So this is 6. So I'm just going to go 5 times 6 or 6 times 5, and I get 30. Okay, so the area of this is 30 square units, meaning I need 30 squares to cover it. Well, what do R and P have in common? Well, area of R was 30. The area of P was 30. So they have the same area. Okay, even though this one's like a tilted rectangle, it's a parallelogram. Okay, and this one is, well, it just has 90 degrees in the corners, right? It's just a nice vertical, horizontal, whatever, rectangle. They both have the same area. So I want you to understand that if you take the area of a parallelogram, any parallelogram, sorry if I'm spelling that wrong, it's going to be, well, what they say is base times height, okay? Length times width. But you have to look for the 90 degrees. The 90, like, you look where, yeah, you just got to look for the 90-degree angle symbol. And that is going to be this right here. Okay? Wherever that is, wherever the two things come at a 90-degree angle, that's going to be your base and your height. So if you look up here, okay, and again, sorry, I'm trying to really make this come out here. If I look right here, not what I wanted to do. Sorry. If I look at this figure right here, okay, I don't see any 90-degree angles, okay? But if I count again, right? 1, 2, 3, 4, 5. This right here is 5, okay? Now its height, if I were to bring in a 90-degree angle, this would be 1, 2, 3, 4, 5, 6. Notice it's still going to be height of 6. And guess what 5 times 6 is? It's 30. Okay? So area of a parallelogram does not have to be this complicated. Okay? Just find its vertical height and its width and just multiply those numbers together.